We will now turn to an example where there is a categorical variable with more than two categories. So a marketing firm wants to know whether two new promotions are better than the current marketing strategy. There are three strategies in total. The current one, which we call the control, no promotion, promotion 1, or promotion 2. The marketing company collects data on sales before and after the promotion, and they compute the percentage change. They think maybe percent change is affected by sales volume of different offices, branches, and they want to adjust for that. So we have as a response the percent change in sales. We have the intercept as we always do, and we have the indicators for the three options, no promotion, promotion 1, promotion 2, and then the additional X value for comparative sales. So we have, of course, the exact same problem. There's a linear dependency among the X variables, and specifically current plus promotion 1 plus promotion 2 always equals 1, right? If you are current, then the other two promotions are 0. If you are in promotion 1, then the other two are 0. There's exactly one of them is 1. And the intercept is also 1, and that means there's a linear dependency between the columns. We arrive at the exact same solution. We remove one of the indicator variables to find to be able to get the inverse. Now, here we remove the indicator variables corresponding to current. We call this the baseline. The one that doesn't appear is the baseline. And so our model now is percent change. Then we have intercept in two indicator variables for the promotions, the comp sales, and yeah, that was it. So we can look at that a little bit graphically to get an idea of what's going on. It's always a good idea to look at graphs. And as always, I have the code here. You can look at it. We have plotted the response variable percent change as a function of the X variable comp sales. And if you run the slope over that, then, well, you get a slightly decreasing line. It's unclear whether this is significant or not. All right. Alternatively, you could also look at box plots for the three promotions. This gives you an idea that maybe promotion 1 works better, but it's unclear because this visualization does not adjust for the comp sales variable. And also in box plots, this is the 25th, this is the 75th quantile. And we don't know whether these two things are significantly different, but it gives us an idea of what's going on. If anything works here, then it's probably promotion 1. So we run the regression, and the question for you now is, did promotion 2 here, lead to greater sales relative to the control, no promotion? You see promotion 2 corresponds to X2, and I will leave you to answer this question and move on to the next slide. When we have 3 categories or any number of categories, we have to leave one category out. And that category is called the baseline category. And the interpretation of the indicator, any of the indicator variables, is always relative to the baseline category. That's clear when you have male, female. You leave female out, then male is relative to what the females have. But it's maybe not as obvious when you have 3 of them. So it's always just promotion 1 relative to the baseline, which was the current design. So, and as always, it's the average. So the coefficient of X1, promotion 1, refers to the average increase in percent sales due to promotion 1 as compared to no promotion, adjusted for other variables in the model. And that brings us to another clicker question. This is the same regression, but the question now is promotion 1 better than promotion 2, or the reverse? Or it's not possible to say. So I will now go to the next slide. I'll leave you to answer this. We're going to play with this model a little more. And we're playing in the way that I want to show you that this corresponds to 3 parallel lines. The 3 lines corresponding 1 to each of the categories of promotion or promotion. So if in this regression equation you have no promotion, then this indicator is 0 and this indicator is 0, and you are left with beta 0 and the comp sales. So this first problem. If one of the indicators is turned on, then you get beta 0 plus whatever indicator is turned on, either beta 1 or beta 2. The indicator itself is 1, so it's beta 1 times 1, so just beta 1. And then, of course, still the comp sales. So depending on which promotion is turned on, you get either beta 0 plus beta 1 or beta 0 plus beta 2. Now, what you see here, you have a regression with only one continuous x variable. And then you have 3 different intercepts. You have beta 0, you have a new intercept that is beta 0 plus beta 1, and a third intercept, which is beta 0 plus beta 2. So we have 3 lines with different intercepts. So these are 3 parallel lines, right? The coefficient for beta 2 is the same for all of them. Beta 2, beta 4, the comp sales. So you may not be able to see beta 0 because it's so small in this example, but the point holds that the 3 lines are parallel. And yeah, that's the easiest way to say it. So we have 3 parallel lines that are induced by the indicator variables. Okay. What happens when we leave out a different baseline category? So here, for example, instead of leaving out promotion no, I'm gonna now leave out X1. So I'm leaving out promotion 1. So I have an indicator for no promotion, meaning current state of affairs, and the second promotion. Okay, things change around a little bit. And on the next slide, we have a comparison where here we have indicators of promotion 1 and 2. And here we have indicators of no promotion and promotion 2. What is the same and what's different? Let's first look at the other unaffected variable, comp sales. Comp sales is the same here and here, not affected. What is affected are the indicator variables themselves, which have different values, right? So the one that there's in common is x2 is here 2.8 and there minus 5.5. And the constant also has different values in those 2 regressions. Now the values show up a little bit here. Similar values show up because here I have 8.41 and here I have minus 8.41. And if you think about it a little harder, it has to be such that you get the same interpretation from the model, right? So it is not a surprise that the numbers show up in slightly different combinations here. And the comparison between x2 and x1 is really easy now because we left out x1. So we can directly compare x2 versus the left out category, and we see that the difference is minus 5.59. And x2 is not as good as x1. So, but is it statistically different? Is promotion 1 better than promotion 2? So that's equivalent to asking, is the difference significantly greater than 0? And the difference is beta 1 minus beta 2. And well, here it was easy to answer because one of them was 0, right? The coefficient of the left out category, the baseline category, is 0. So I know exactly it's minus 5.59. Here I have a beta 1 and a beta 2, and I have to take the difference. And this will also turn out to be exactly 5.59. It has to, because these things have to give the same answer in the end. So this is an example of a contrast. So if I don't, it's an example of a contrast, meaning a linear combination. And what to do with this contrast and how to compute a standard error is something we will discuss in a later lecture. All right, that concludes this segment.